after office hours comes excellence. After office hours comes a new generation of Salesforce AI trailblazers. Welcome to the After Office Hours 5-day Agentforce intensive training. From 01 to 05 December 2025, 7 p.m. to 8:30 p.m. Iced. Powered by Salesforce User Group Chennai. A massive shout out to our co-host leaders across India. Thank you, Trailblazers, for uniting this community. Together, we learn. Together, we lead. After office hours, we ignite the force. Agentforce rising, we're the future source. Trailblazing mind, we break down the doors. Learn AI, build AI, and unlock more. After office hours, we level up strong. 5-type power, the journey's on. This is where the next big legends are born. Agentforce, we run the loud future from home. Over day wind-up, Red LM Foundations. Transformers, attention, generation begins! On a day 2, prompt engineering, talk with AI like a boss, precise and winning! On a day 3, Agentforce Agents, topics, actions, instructions, automate the magic, Agentforce actions, flows, apex, services, superpowers unlocked. Day 5, the grand Agentforce demo, service marketing, ask me anything, full excellence mode, activate after office hours.
Hi everyone, and I welcome you back to day 3 of our after our series. So the theme is more towards on LLMs, understanding LLMs and Agentforce. So day 1 and day 2, we've dissected what is LLM all about. Now we'll step into agentic AI and understand Agentforce more from a theoretical point of view, right? So before we dive in, I just want to reiterate our speaker's note. So first, these sessions are designed for audience who have prior experience or knowledge in Salesforce and have basic understanding of what artificial intelligence is all about. Okay, and from day 1 to day 5, everything is a continuous session. So if you miss one, the context for the next session would be missed. So try to keep up with the session. And all of this after our series, we'll cover theoretical information from basic to intermediate. This would really help you to create a baseline and perform practical use cases in your demo work. So it would not lead you to create an entire agentic ecosystem from end to end, but basic information of how or like what to search, what sort of research information you have to get. And the next one is the content that you see in this PPT deck in this session today. It's as of 2025 October. So any updates that happened after that would not be available in this session. And as discussed by Anand, like the sessions will be recorded, and once the recording is available, he'll upload in the YouTube later. And so whatever information or the images that you see in this session, we don't own it, rather we researched and picked those information from reliable sources. So they are the owners, like in contrast, like we are not the owners for the image that you see in this session, the entire session, right? And also a quick point to note is that like we saw members increasingly asking for specific Agentforce related questions, workings of Agentforce, right? But our recommendation is to understand the theoretical information just to create your baseline. So without any information of how Agentforce works or what sort of information do we need to acquire in order to excel in Agentforce or create a agent, right? So until we don't know it, we won't be able to fully create an entire agent from scratch. Okay, so day 1, we'll have a refresher. Day one, we started with what is artificial intelligence all about. How does it actually work, right? Then we saw concepts within artificial intelligence. Then we've dissected, okay, what are the subsets within artificial intelligence? Starting with AI, then we went on to machine learning, then we went on to deep learning, then we had generative AI, in which you have LLM and traditional machine learning models, upcoming models such as your large concept models, large action model, which we will be deep diving shortly in the session, and vision language model, a mass language model, and segment anything models, right? And after that, like for every LLM, you have something called a transformer architecture, which is the base, which encodes any information from a human into a machine readable format and decodes it back from a machine readable format to a human readable format. And within a transformer architecture, you have the different layers, forward networks, and attention mechanisms, and positional encoding, so on and so forth. And we've dissected what is tokenization all about, what is attention mechanisms, and what are the sampling techniques specifically for text generation. So examples like your regression, k-means clustering, some deterministic and stochastic methods. So this is what we saw in day one. In day two, we've talked about more in detail about what are the different large language models and how do we actually segregate or segment them based on the architecture, based on the access type, and based on the functionality and training, right? Then we saw how does an LLM gets actually invoked. Uh, Maybe from a layman perspective, how does an application get information or like pass on this information from UI to your LLM, and what information does it get back from LLM? And we have talked about what is a prompt all about, what are the concepts or like what is required in a prompt that you're going to provide for the LLM, and what are the types of LLM that you have, what is prompt engineering specifically, what are the key concepts of prompt engineering, and best practices and consideration when you engineer a prompt from scratch. And we saw a little bit of what are the AI concepts within Salesforce, such as like Einstein, GPT, Agentforce 360, and your prompt builder within the same umbrella, right? So any specific questions you have, please use chat. If you have any specific questions that you had on day two, you can ask in the chat and we'll be happy to answer. Simultaneously, I'll walk you through today's agenda. So for today, we'll touch base more on what is agent all about. I think like many of you would have understanding or like basic understanding of what agent is, but we'll talk about what is the definition of a agent. Before agent, what did we actually have, right? And what do you like when do you consider a system to be an agent, right? And what is the evolution of Agentforce 360? From where did it start, and what is the current status of Salesforce Agentforce 360? What are the capabilities within Agentforce? Types of agents, specifically on a generic level, and also from Salesforce perspective, what are the different agents from an architectural standpoint? What is topic? What is actions, and what are instructions in a topic? And we'll introduce you to action builder. So today we'll focus on showcasing different screens of what Agentforce is all about. And omni-channel connectivity, maybe we'll check we have some additional time today. If not, this specific part will be moved on to day 4. Okay, right. So first, maybe I'll switch back to the agenda. So from your perspective, what do you think an agent is all about? Any answers in chat? When do you consider a system to be an agent? Okay, simulates human, someone who takes action, okay, trained with predefined instructions, okay. assisting both internal and okay. Without manual intervention, performs actions. Great, which performs the task. Agent is assistant planned for the planned work. Interesting. Agents help our work to be easier. An automation like human for small work. Okay. Autonomous task oriented assistant. Great. I see a lot of answers and everything has like different perspective to it. Okay. Great. So maybe I'll start with like introducing you to the familiar concept of what is AI tools all about. What is the differentiation factor from an AI tool to an assistant and from an AI assistant to an AI agent? Okay. So specifically when we going to talk about agents, we also need to know what are AI tools about, because like many of you talked some simple tasks that can be predefined, and the system can perform those specific tasks, right? So if we talk about predefining or pre-configure steps, that would become a tool, an AI tools, because it performs only that specific task and you already pre-trained it, right? So for any simple tasks, if an system can do it, but it requires your intervention or like any human intervention step by step. Say for example, you give a task for a system to work upon. As said, like if it has any predefined steps, if it would actually do it. If not, it would require your intervention from time to time to understand which action should take or like which step it should take, right? So as said, like it cannot work autonomously. It always require a human supervisor or like an intervention whenever it requires additional assistance. So some of the examples could be your Tableau, Grammarly, Microsoft Excel. So these are designed specifically for a task, for simple task. But if you ask it to do any other tasks that are not part of this environment, it will always reject or it cannot perform because it does not have any context behind it, right? So these are AI tools. An upgraded version, we'll go to AI assistants, right? So here, instead of simple tasks, it can perform routine tasks without human or with minimal human intervention, because it requires interaction with the human from time to time to understand whether it's doing the right job or not. Okay. So it always learns something because it interacts with a human, and based on the interaction, it gets the feedback and passes over to the system. So there's a feedback mechanism in place, and always it trains itself based on the information that it gets. But apart from, as said, like with tools, it has a environment around it. So apart from the environment, it cannot perform any other tasks autonomously. Okay. So examples could be your Apple Siri or Alexa. So these are some of the assistants that can do specific tasks, but it requires human to initiate that conversation, right? So that's why we call them as AI assistants. They cannot do or like perform any task independently without any information from you. So that's why we term them as AI assistants. Now an upgraded version, right now what we stand is AI agents. So here it performs autonomous decision making and complex task creation, because whenever you define a clear objective to it, say for example, you need something to be done, what it does is it analyzes the entire context and it creates a step-by-step plan. Step 1, step 2, step 3, and step 4, and so on. And each step is actually a separate task for itself. So it does not ask, or it requires only minimal intervention. So those are termed as agents. It can learn and adapt to any situations because the environment is not limited to one single context or one single data set. Like it can have access to multiple data sets, multiple tool sets altogether. So it can learn, adapt. Say for example, for step 1, if it requires any human intervention, next time if you ask the same query, step 1 would not ask for human intervention because it already knows what sort of intervention or what sort of information that you're going to provide. So that's how AI agents are capable enough to understand the one that is in front of you, so that they can perform the tasks equally or like better. So they can augment something. So here some of the examples could be your Tesla autopilot. Many of you might have gone through or like know what is autopilot all about in Tesla. You have IBM Watson and you have OpenAI 5 framework. So this is an interesting framework wherein if some of you are game enthusiasts, like OpenAI 5 framework is a AI driven framework that plays with online players. It's fully a automated AI agent specifically. The task is only to play Dota and understand the hidden patterns within Dota for separate heroes. So that's pretty interesting for game enthusiasts. So right now we've talked about tools, assistants, AI assistants, and AI agents. Then I want to introduce you to the types of AI agents specifically. Like it's not confined to these 5, rather you have like n number of agents, but on a broader category we want to segment or segregate them onto these 5. So the first one would be an internal or an employee agent specifically. So you might have come across an Agentforce if you have created any agent. So this is an advanced version of your Copilot. Salesforce Copilot, which was initially there but retired right now. So employee agent specifically assists anyone who uses the application. Say for example, if an agent is employed somewhere within an application, it can be a CRM, it can be an ERP. So if you want any information pertaining to that environment, you can use your employee agent, specifically designed to assist your employees or the business employees and makes their life easier. Any of the complex information that you have to do some processing, you can leave it to employee agent and it can fetch additional information and also adds context to it as well. Okay. Next, you have sales coach. Sales coach are like an assistance that helps or coaches salesperson specifically. So you might have come across this one as well. It does not directly deal with any of the leads or any of the customers, but rather it helps the sales reps within the business to understand what are the next steps, what can be done in order to close this deal quickly. So intelligently understands what sort of information that is currently available at hand for a lead or for a customer specifically and close a lead. So that's sales coach for you. Then you have classic examples like sales rep, service agent, and marketing agent. So as name suggests, sales reps are autonomous agents that can help business to close the deals very easily. So it works on assigned opportunities and also identifies like specific decision points, has some conversation, sends across case emails, generated emails, personalized ones to the customers to get the job done quicker. Service agents, similar, like it's an autonomous L1 agent. So most of the companies right now have agents in place. So if you have any basic queries, so you can very well see like it's an agent where you have communication. So if you have any queries related to some of the services, it directly reaches out to the knowledge bank, or it also might have access to other specific data sets as well. Based on the information that it collects, it analyzes and performs actions to answer your queries as much as possible. If not, it redirects you to the L2 support, which is your human intervention as of now. So classic example would be right now for whenever you raise any case with Salesforce, first up you'll talk with the service agent, then it classifies your case accordingly based on the information that you provide. Then after that it will get assigned to a human agent, and then the conversation starts where you go back and forth with a human agent to close your case. So that's service agent for you. Then the marketing agent. So it's a kind of a new concept where it assists the marketing team in order to create better content, better campaigns altogether. So what it does is it helps the marketers to identify hidden patterns. It might not be available for the marketers directly, but it can analyze the data sets that it has at hand, right? And it also can suggest when to send across a email for a specific user, what sort of content, what sort of subject line, pre-header. So all of those information can be provided to the marketer so that they can better perform their marketing campaigns. So these are the broader categories, but as said, like there are n number of agents that you can create and mold according to the business needs. So it's not confined to only these 5, but rather you have many. Next, we'll talk about agentic ecosystem. So we've talked about the types of an agent, but how does an agent work in a specific environment or a specific ecosystem, right? So the first one would be single agents or like monophonic agent ecosystem, where you have multiple or like n number of agents deployed in your business, say for example, and a customer reaches out and asks for a specific question. What it does is either you reach out to the agent takes that information to an orchestrator. Here in single agents, it's a human. So what it does is, and after that in the background, the orchestrator gets information from the frontline service agent that you see in the screen. They use additional employee agents such as inventory specialist and logistics agent. They get additional information, and that information is passed back directly to the customer. So when you see the communication that is happening, there is nowhere that the communication between one agent and the other coincides, right? This is specifically for an agent can only communicate with a human service rep. So examples for this one is your service agent, the frontline L1 agent, and here you have an employee agent which takes care of specifically to understand your inventory needs. And this agent can talk to any of the order management or order fulfillment systems that if you have an external source, so it can get information from the external source and gives that information to the service rep, and the service rep can pass on this information to the customer. So here the agent can perform a specific task, but they cannot talk with one another, as you can see here, right? So that's single agent ecosystem for you. An evolved version. Yes, we have polyphonic. A polyphonic is nothing but you have a orchestrator, which is an agent itself, and agents can communicate with the agent and get additional information, and it gets passed on to the service. So the communication, as you can see here, customer reaches out to the L1 agent. L1 agent in turn passes information to the orchestrator, which is an agent itself. And what it does is it orchestrates what information or what sort of information has to go to which agent specifically, as you can see here, right? And what it does is this information is passed on back to the frontline service agent, and it can service the customer directly. So the orchestrator can be a human service rep, but it can also be an autonomous AI agent altogether. But in order to better understand this, I'll go back to one more slide, and here you can see there are different components to an ecosystem altogether, right? So the first one, whenever you want agents to talk or agents to communicate, you need some sort of an orchestration layer. So that's where here we create an orchestration agent specifically. So this agent, what it does is the main idea, the main task of this agent is to communicate and redirect the task that is appropriate for a specific agent, right? So that is orchestration agent. So orchestration layer specifically, and you have agents and autonomous agents. Right now you saw you have L1 agents, then you have frontline service agents, then you have additional logistics agent, and you have inventory agent. So these are separate autonomous entities within one single ecosystem. How does it actually communicate? The communication happens from one agent to the other. There are a lot of protocols currently available. You might have came across a protocol called MCP, and you have A2A, right? So these are some of the protocols that would help an autonomous agent to talk with a tool or to talk with an agent itself. So that's where your event driven communication comes in. So it's an one-to-one communication where you have directly communicated from an orchestration agent to one agent, and from the specific agent back to the orchestration agent, right? And the governed autonomy, this is mainly because you need to have some sort of guardrail specifically, and you also need to audit time to time to understand whether how does the communication happens. Why? Because it's not required or it's not recommended for the inventory specialist to directly communicate with the customer, because it does not have sufficient information of how to communicate, what sort of information that you need to hold, and what sort of information that you have to show to the customer. All this information will be available only to the frontline service agent, because it's tailored to do or tailored to talk to the customer. That's it. If you provide any information, it can add on to that information, but it cannot create any additional information, right? So here, that's the governed autonomy. So within any agentic ecosystem, you would have all of these four components, which are the orchestration layer, intelligent agents ecosystem, event driven communication, and governed autonomy, right? But here in the polyphonic one, if you could see, agent does not talk with one another apart from the orchestration agent, right? Because there's no connectivity directly with inventory specialist to frontline service agent or inventory specialist to logistics agent. They are in an ecosystem, but the central point of communication would be your orchestration agent. Orchestration agent can be, as I said, like it can be an autonomous one, or the service rep can orchestrate entirely in form of an orchestration agent, right? But in order to have an advanced ecosystem, there's a third architecture all combined, like whatever we talked about. So here what happens is, if you have additional agents, these are some of the agents that are in a specific ecosystem but can talk with one another. When an agent can talk with another, it can be possible only via specific protocols. So it's an agent to agent protocol. That's a separate topic. But here the concept to understand is, you have separate agents and the agent can freely communicate with one another. It can talk with your orchestration agent, it can talk with your customer agent specifically. Whenever a customer has a query, they reach out to the frontline service agent. It can pass on this information to the orchestration agent, and the orchestration agent can get additional information from inventory specialist and logistics, and it can pass on this information to a altogether a different agent where it has additional information of how to speak to a customer. So in this screen and in this screen, you have a difference. The difference is, here always there's a monitoring point where the orchestration agent is monitored continuously by a service rep in the background. But here there's no line to it, as you can see here. So freely a customer can communicate with an agent without knowing that they are actually an autonomous agent, right? And the service reps can monitor, but on a dashboard basis, like they can try to understand like how the orchestration agents are working hard, or how all of the other customer agents are actually working, those sorts of information that they get. But they do not have any contact with customer, as you can see here. So this is ensemble or a complex agentic mesh ecosystem that we are talking about. Okay, right. So we've talked about types of agent, we have talked about types of ecosystem. We are seeing the positives of an agent, like it can work autonomous, it can perform any task without any human intervention, it can dissect an objective, and based on that it can create a specific task, subtask to itself. It can communicate with other agents and get the task done. It can reach out to a specific tool and get sufficient information. All those are right, but we also need to know what are the different challenges that are available when you are using an AI agent, right? So the first challenge or the first concern that we see is data privacy. and the security as well. So here, why? Because we've talking this as a challenge is huge sets of data are going to be introduced to this age, right? And there's a possibility where there can be an attack or a potential target of this data breach that are going to happen via an age. So all, when you're going to deploy this as an employee agent, or if you're going to deploy this as a customer service agent have access to case information. Case information, if it has additional access to your accounts or contact information, which is your PI data, any target or compromise of your AI agent can have hacker to get information from the system via this AI agent. So that's why we have this as a first challenge. The second challenge is the ethical ones. So instead of having a bias, because AI agents are trained in a specific way to speak or to act without any biases. So if there have been any bias introduced, the training data would become distorted, and it can lead to unfair or like compromised services with AI agents specifically. So here, this is mainly because when there's an ethical challenge, uh, any discrimination can happen. So it can if it can discriminate, like whoever is talking with the AI agent specifically. So if person one and person two, if it discriminates that this person is having certain attributes and the person two is having certain attributes, we want AI agent to be unbiased and service without any discrimination. But if it has any ethical challenges, then we need to address it specifically at any point of time. We have to completely retrain the model altogether with the proper training data, right? And the technical complexities, if you're going to create an AI agent from scratch, and say for example, for an enterprise, if it has like 10 or like 50 different agents that you're going to employ, you need to be technically sound enough to understand what agent does what work, and which agent should talk to which agent. So this is where your additional information of the data or the agent mapping comes into play. So, and the fourth one is your computational requirements. Say, as said, like if you have 50 different agents that are deployed, and all of the agents are active at any given point of time, so that would require a lot of computational resources, and also the incoming traffic. If the incoming traffic is high, and if all of the users talk with the agents, say if they are like L1 service agents, the level of computational resource that need to be available for it to better perform is very huge. So we need to understand how to reduce or how to optimize your computational requirements as well. So we've talked about the challenges uh, here and why does it actually matter. We also need to know how it can be mitigated, right? So in terms of data privacy and security, you need to have proper governance mechanism. So data governance should be available, and strict access controls for users who have access to the agents, right? Specifically to alter or to make any sort of changes, there need to be access control. So every mitigation tactic that we are going to see right now, Salesforce has addressed to it. And the first one is you need to have special or like specific profiles and permission sets for in order to change any of the agents, right? So that's access control for you, and you have trust layer as well to understand or to check whether you have sufficient information or sufficient access to reach any of the data that is available for an AI agent to work with. Ethical challenges and technical complexities both require human supervision. This is mainly because you always need to understand how your agents actually work. If you don't know, you need to have a dashboard to check on a monitoring basis, because it has high impact on how it can discriminate and how does it actually service your customers, right? And also for technical complexities as well, you need to understand what type of conversation or what sort of information that is passed from one agent to the other. So you have specific activity logs to capture this information, debug the information, and find out whether That's the expected behavior of an AI agent. So that's for technical complexities. For computational requirements, since if you're going to use any of external models to create or like to generate something from scratch, so you need to use optimized models. Specifically, this is where your prompt engineering comes in. So engineer a prompt so that it takes less number of tokens, which in turn gets you to less number of computational resources, right? We look at the next set of challenges. So here we have multi-agent system challenge. So as said, increasing number of agents in a specific ecosystem increases your complexity, and also you need to employ a specific person to trace and understand what sort of conversations each and every agent is actually making with the customer, and also with the agent itself if you have already used A2A protocol, right? You need to understand what the agent is all about, what sort of tasks that it actually performs, what topics that are available for an agent to work with, what sort of actions that are available for that specific topic. So as a mitigation tactic, you need to have a unique identifier for each and every agent, specifically to identify this agent is specifically for these topics, this agent is specifically for these topics, and within the topic you have actions as well. And the second challenge that we see here is infinite feedback loop. This is mainly because say for example, any actions that an agent perform, it continuously processes that information and passed on the feedback loop again and again and again. So until or unless it has a clear instruction of what to do and what not to do, any feedback that comes back to the processing system would not give a complete or a holistic picture of what is the desired outcome. So in order to do that, if it has any infinite loopback mechanisms in place, say for example, if it infinitely runs on giving the feedback, getting the information, giving the feedback, you need to have an interruption capability. So at any point of time, a human agent is capable enough or have access or sufficient information or controls to stop an agent from being active and having an infinite feedback loops, right? And the third one would be any task that requires emotional intelligence. So right now, in terms of understanding the human intent, like many of the LLMs understand of what the intent is all about, understands the sentiment of the query altogether, but it is increasingly required to understand the human, what sort of tone that they're actually using at a specific point of time. Say for example, if you have created an agent specifically for a medical or a hospital specifically, and if you are typing in a query to understand whether you have any ambulances near, the tone and the format would be required for the agent to highly prioritize this and pass on this information to the human agent as soon as possible, because there an immediate support is actually required. So that's the sort of human intelligence or the emotional intelligence that the agent is actually requiring, but at many parts it's actually missing here. For now, we need to have a human supervision, mainly to understand how does the agents actually take human empathy into consideration. How does it actually deal with the query? Say for example, when you ask a specific question and the similar question with comma please, the sentiment itself is actually changing. So something that is ordering or a commanding tone, the next one would be some kind of a request. So this is how the prompts have to be engineered in order to get a sufficient response quicker and faster, and also to make sure the agent understands your need, your environment or the context around it, so that it can pass on this information from itself to the human, so that it can process the information as soon as possible and get the job done. So as of now, I said, like we don't have any agents that understands human emotional intelligence end to end. So what it does is, you are going to pass on this information from an agent to a human agent. But in order to do that, you need to let the agent know of what you're requiring at that specific point of time. Okay. And the final one would be autonomous action. So there are high stakes when an agent takes an autonomous action without a human intervention. Say it's a day-to-day task, a mundane task that doesn't have any impact, even if it goes wrong, well and good, it can be autonomous. But what if it has a high stake towards it? So that's where you need a human supervision as of now, just to make sure that the end-to-end task is performed as expected. If not, a human intervention is actually required. So interruption and also intervention, where an information can be passed from an AI agent to the human agent, so they can deliver it better if anything goes southways. So these are some of the challenges that we've saw and the mitigation tactics. Salesforce has touched on each and every challenge that we saw right now, and they mitigated using some of the in-house concepts such as trust layer, and you have access controls in place, you have interruption capabilities, you have a dashboard that continuously monitors what the agent is doing, you have activity logs to capture interaction of an agent. So everything is available in Salesforce as of now. It's just that like there is no autonomous agents currently in play. Moving on. So from start, we've talked about agents. We've talked about where does agents come from tools and from assistants to agents. We have talked about types of agents, generic ones, and we have talked about ecosystem. We've also talked about the challenges. Right now, I want to introduce you to Salesforce AI specifically and their evolution, starting from 2014 until now. You can see the entire trajectory from here. So on 2016, Salesforce started Salesforce Einstein, and gradually they moved on to Einstein GPT, where on to 2016, it has a capability to understand human readable format, where any of the natural language can be provided, and based on that information within your CRM org would be brought in and provided as soon as possible via global search. Then you had vision and language specifically to capture information from the image and also understand different languages. Then you have Einstein bots. Many of you might have experience in using Einstein bots. Those are predefined sets of tasks that you create and that acts as a bot. So any information, it has a series of steps. It's either choosing A or choosing B or choosing C. So everything is predetermined. It does not think on its own. It doesn't have any logical reasoning capabilities, right? Then you have prediction builder. Then you have conversation insights. Then you have recommendation builder based on the prior information of all human interactions, may be captured via website or via any of the external sources, brought in. Based on the information that is at hand, the data is trained, and based on that, the recommendations are provided via the recommendation builder. And then you have Einstein search. Then in 2022, you could see something called CodeGen LLM and Einstein for developers. So Einstein for developers specifically for code generation, and also CodeGen LLM. It's a proprietary LLM where it talks about providing any information in forms of a natural language, and based on that, it understands the natural language and responds it back based on what the user is requiring all about. So that's CodeGen for you. Then you have Einstein GPT. Then you have XGen. XGen is a proprietary one from Salesforce, which is a separate LLM altogether. And you have Apex Guru within Sales Insights. Then you have SFR, Salesforce Embedding. Then you have Ensemble, RAG. RAG is retrieval augmentation generation. Then you have XLAM, a proprietary one from Salesforce. This is the concept of large action models that we've talked about. So this is applied in currently in Agentforce 360, where whenever you give any query, when you ask certain question, or when you want the agent to perform any task, it understands the overall uh, agenda to it, or the objective to it, and then it creates a detailed plan. Once the plan is created, it segments the plan accordingly in terms of subtask. So that's where your XLAM comes in. Then you have Einstein for developers, and right now you have Atlas reasoning engine. So this is termed as the brain behind Agentforce 360, where it thinks, understands the human context, and based on that takes necessary action of how to address a specific tasks. So that is what is currently happening in 2025. And there are other interesting components in play, where you have XMM. So it's a masked language model specifically, and it talks about understanding your inputs other than text. So maybe going forward, or in the near future, you can provide an image, or you can provide a video, or any sort of inputs in any formats, and Einstein or Agentforce agents can dissect the information, and based on that it can provide information back to you of like what the input is all about. So that's where our team is actually heading. So there's a specific research uh, department available in with Salesforce. Please do check that out. There are like interesting concept papers that are currently published, interesting to read. Okay, so we've talked about Agentforce 360, where it started, and what's the current status of Agentforce. Initially, we had Einstein AI. Right now, we have Agentforce. So I want to specifically take some time to talk about the differences between Einstein AI and Agentforce. So Einstein specifically for prediction, for recommending something, and for um, assisting an employee, or an internal user with additional information. So that's augmenting your CRM information. So any insights based on the information that it has, it predicts and provides that information, and it also provides you with additional insights that can be actionable. So that's Einstein AI for you. Agentforce, completely autonomous. It does not require any human. So Einstein AI captures that information and provides it to the user so they can action it. Whereas Agentforce, it gets that information and itself performs that specific task. Say, for example, if it's enabled to do so, it can autonomously perform without any human intervention. It can take any decisions based on the prior information that it has, and better performs a task without any human intervention as such. Okay. Then Einstein is actually reactive, and whenever you ask a question to Einstein, only then it would actually respond. But in Agentforce, if you enable it to be proactive and agent enough to talk with the other agents, it can independently initiate a workflow, send across a notifications, like start any action in the background. Anything is possible via Agentforce agents. So Einstein AI on a whole, it's an assistant. It can help an individual, and it can augment their operational capabilities. So instead of processing something, it's already processed, but that information has to be fed to a human so that they can take it to the next level. But for Agentforce agents, they can themselves perform a specific task without any human intervention. They can create an entire end-to-end plan to achieve a specific objective. Okay. Right. So we're currently talking about Agentforce. So what are the building blocks in Agentforce, or Agentforce 360 specifically? So we'll start with talking about where does Agentforce agents can be embedded. Where do you leverage this information? Right? So it starts with voice. You can use it in Slack. You can use it via flows and API, any applications on mobile, any digital channel, robotics. So there are interesting use cases where you can leverage Agentforce. Maybe using headless API, you can create an entire web page, and you can have it as a have it as a block where you can talk with the agent. Instead of having standard UI, you can have a customized UI as well, specifically through headless API. Anything is possible. And in order to supervise and optimize it, right? So always you need to have a key performance indicators, KPI specifically for AI. There's a interesting blog that is currently written. If like many of you came across this, so there's something called Everse. Everse is nothing but instead of having a testing center, Salesforce itself provides an environment altogether. Say if your business is a telecom provider. So through Everse, it's possible where Salesforce creates an entire ecosystem, entire data set for the agent specifically to be trained. Instead of you creating something, it's out of the box available. So the name is called Everse. Please do check that out. And the last one is deploy, monitor, and optimize it, iterate and fine tune the topics, actions, the scope within the topic, the classification description within the topic, and optimize the actions whenever required. Okay. Then through all this, we've talked about creating an agent, what sort of steps that we need to take, but you also need to understand the foundational concepts as well. So there is something called reasoning, trust, and performance. Reasoning is your atlas reasoning engine, where it acts as the brain. It understands the human query. Based on that, it decides autonomously to create a plan, and based on the plan, it acts on it autonomously without any human intervention, as said. And trust layer is your Einstein trust layer. And you have performance, where continuously monitoring the performance through agent dashboard, and also optimizing the performance. Say for example, if you're using a prompt builder to create prompt templates, specifically engineer your prompt to use less number of tokens, or to optimize level of tokens, so that it gets better results with the less number of tokens. So that's where performance comes in. Then you have the data lakes, where you have the data sets that are currently available, unstructured data, different business apps that can be used, and engagement data from different third-party tools. So all this combined is your Agentforce agents. So without any of the topics that we see here, it's not possible for us to create, or at least understand, to create an autonomous agent. Okay, great. So yes, moving on. We have talked about the capabilities or the building blocks. These are some touch points that I want to iterate again. So choose optimal model, create an agentic mesh. So if you have a agent ecosystem, and if you want your agents to talk with one another without any human intervention based on the query, create a better agentic mesh through A2A protocol. And use Salesforce trust architecture, build safety protocols like having access restrictions, and also frameworks that reduces the level of information that is shown to the agents. Then you have context memory, maintain extensive customer histories. This is specifically to address any customer that has repeated questions in one single chat, right? So need to have lot or a large context memory to understand the entire context in order to better serve the customer. And deep understanding, where agents is said to have accepting inputs such as image or video or audio, but right now it's only capable of understanding text. There are large improvements that are currently in play, which would enable users to provide inputs such as image, video, and audio, and so on and so forth. Okay, so we've talked about types of agent in a generic way, but I want to introduce you to types of agent in Agentforce specifically. So number one, conversational agents. So plain and simple, customer uses the specific agent to converse something provides information in form of a query, and based on that, it takes a necessary action. It has access to the Salesforce org. It also has access to external applications if you're using any external connected app specifically, right? So these are plain and simple and straightforward. Proactive agents are something that are in the background. They are always proactive. So it requires any event to happen in order to pass on this information. Say, for example, you need to send across a notification in terms of the bounce rate. If the bounce rate is high, say if the bounce rate exceeds beyond 2 or 3%, you need to send across an email or you need to notify a certain user. What it does is when this event actually happens, you pass on this information or you create a notification. The agents itself creates a notification and sends across this information. So there are n number of events that can be created, and you can employ these agents specifically for this task to be proactive and perform the task when an event occurs. Okay. Next, a slight variation of a proactive agent. These are called ambient agent. So ambient agents are also proactive. So they are in the background, they continuously run, but they do not require any specific events to occur, right? So there is no pre-configured event in place. Rather, it intelligently decides whether to pass on any information or not. If you need certain day-to-day task that needs to be performed, it can actually do. So it supports or it augments the employee efficiency. Say an employee is employed only for 8 hours of work. You can use this agent specifically in the background to perform any day-to-day task that are repetitive when the employee is not available. So it's not replacing the employee directly, rather it augmenting their capabilities. So that's ambient agent for you. Now we have autonomous agents. So whenever you give an objective, it clearly slice and dices on what to do, what not to do, what sort of plan that is going to take, what are the subtasks, and what sort of information that it requires either from Salesforce or from an external ecosystem. So it uses all of its capabilities, creates a detailed plan, performs the action, and then gives the output. So whenever you start, you only have the output, rather there is no interruption of or a human intervention required for the agent to work upon. So that's why we call these are autonomous agents. Autonomous agents, in clubbing one or more autonomous agents, you have collaborative agents. It can be autonomous or it can be proactive or it can be a conversational agent, anything. But if it's in an agentic mesh, information passed on from human to one agent, what it does is it slices that information, creates a subtasks as required. Since we are talking about autonomous agents here, then subtasks are passed on to specific agents which are capable enough to do that. Say, for example, I require an order related information, right? So order related information is available in our CRM, but the exact information or where is my order, all those order fulfillment details are in a separate or in a external environment. So what it does is it uses agent 1 to get order related information that's available in Salesforce. It uses agent 2 to communicate with the external tools like an order fulfillment system, get that information and pass it back to the orchestration. So agent 1 gets the information, agent 2 gets the information. Both are clubbed together and passed on as a synthesized combined output, and that output is given to the orchestrator agent where we have a conversation with it. We don't have direct conversation with any of the agents or the collaborative agents within the agent ecosystem. Another good example could be your aggregators. Say if you want to look for a holiday package, you're going to make my trip. So you search for something, say a specific place. What it does is it suggests the next step, whether you're going to book a flight or not, whether you're going to book a train. Then it provides you additional recommendations, or these are some of the sites that are currently available in that specific place. So each and every information that is picked up and shown, these are the jobs that are done by an agent in the background. So simultaneously, agent one would go and check for flight related information. It goes to the aviation website and checks for all of the flights that are specifically to this particular location on this date and time. And the other agent in the background looks for a specific sightseeing, or it can look for any of the interesting information that are currently happening in the location on that specific day or in that specific period of day. Everything works simultaneously and in the background, but we all have that combined output, and we in the UI we only see one output, right? So that's your collaborative agent for you. Okay. So we've talked about Agentforce. We have talked about the types of agent, what are the different ecosystems that are available. I want you to introduce on how it actually works, maybe from a visual perspective. You start with the conversation, you ask for a certain information. Say, what is the recommended product based on my order history? So you have additional information of what to do and what not to do. What the autonomous agent does is it creates a plan using Atlas. It creates a plan of what are the actions that it needs to perform. But in order to understand what actions, it need to classify the question to a relevant topic. So here, since the question is more towards on recommending product based on the order history, it classifies this question to order management topic. And once we have order management topic, within that you have series of instructions. So say there might be an instruction where if you have these sorts of questions, this should be your answer. Or when you have a relevant question, you need to reply something like this. So instructions, you can have a number of instructions to a specific topic. And once you have topic and the instruction chosen, you can go on to the actions that are available to the topic. So Atlas itself recognizes which of the action is better suited for it. So within each action, you have additional information of when to choose this specific action in a topic. So that is a separate concept. And once the agent chooses the action, executes that action, it creates additional information using whatever data that it has, and it generates a output. So based on your order history, we recommend product A that would complement your previous purchase product B. So previous order history would have information in your CRM, and external information of product information if it's available from a different source altogether. So all this combined, you have single output. So starting with the conversation, you create a plan. The plan would have of topic, classifying what sort of topic that it needs to choose, instructions on how to address this particular query, what sort of action it need to take, and once it performs the action, the outcome, right? Sorry. So this is the entire end-to-end flow of how does an autonomous agent thinks and acts. Now we are going to talk about topics, instructions, and actions explained. So I know it's a very theoretical form, but since we wanted to enrich, or we want to empower you with these sorts of descriptive information, if we show something that a very demo or practicality, it would not reach you. But rather, if you have some base information of what is topic all about, what are instructions, what are actions, that would be a better helpful in understanding the concepts when we show the demo later. Okay. So first we have topics, then we have instructions, then we have actions, and these are some of the descriptions. So topic should be based on a specific subject area or domain. Agentforce instructions, step-by-step instructions for an agent to work upon. Agentforce actions, specific actions such as one action at a time. So if you want to query something, that's one action for you. If you want to update a certain record, that's another query, other action for you altogether. So one action can perform one task. Okay. So how to write a topic? So these are the intents, or these are the step-by-step actions that you need to take in order to write a topic altogether. So you need to identify the intent, clear name, clearly classify on how to choose a specific topic based on the query. What are the inputs that are required, instructions, and the necessary actions within the topic. Like this is the screen where you're going to create a topic. You have a name and an API name. Classification description. It's a three or like 1 to 3 sentence where you provide description of when do you actually want the agent to choose this specific topic. Okay. And scope is like you're giving a context of what to do and what not to do, what sort of job the specific topic will empower the agent to perform. And instructions, clear instructions of what should be the input, what should be the output, what sort of actions that you need to take, step-by-step approach, everything you given the instructions. And interestingly, if you could see here at the right, there's a AI generative button. So if you want something, you can write, and if you click on it, Agentforce itself generates the content to it, and it creates a necessary instructions as well. So that's how it's empowered as of now. So some of the examples that I want to talk about, if the topic that you're going to create is order management or order status inquiry specifically, the description would be provide current order status, and instructions would be your tone should be something polite, and the information that you're going to get should be classified in a certain format, say point by point format. And you also need to have additional information of when they are going to get this order, right? So this is the instruction of their output, and the action is get order status API. If the order information is available in a separate environment or an external source, you get this information from that source, massage that information, process it, and based on that you give the output or the outcome. So these are some of the examples: product recommendation, lead qualification, update contact preferences in marketing cloud. Okay, so here an end-to-end example of when you ask for get me my open opportunities which have high probability to close this month. So what happens here is Agentforce picks up this query, and what it does is through classification description, it identifies that general CRM topic is the best suited one. Then after that, you have matching instructions towards it, and it also understands the scope of what to do, what sort of information that it has at hand, what it shouldn't touch. Okay. And after that, it uses query records as an action, mainly because you like that query did not have any specific name or specific opportunity name. Rather, it asks for open opportunities which have high probability. So it creates a SOQL query, and then it executes that query. And after that, it collates all this information and provides you with the output. So the output here is something like this, and this is based on the instructions that you've given or within the specific topic. So a topic could have instructions such as like it should start with opportunity name, it should start with then you need to have stage and amount, and your logical reasoning, what should be the next suggested step. All of this information collated in one single outcome. So this is an end-to-end example of how topics, instructions, and actions work hand in hand. I'll quickly move on to some of the screenshots that we see in Agentforce Action Builder. So here, through Action Builder, you can create numerous actions that can be mapped to a specific topic. So starting with the reference action type, it can be Apex, API, Flow, all the other options that you can see in the screen. Predominantly, you might have used API, Flow, Prompt Template, and Apex, but right now, the action references types are like increasingly available for developers to use. Once you've used Apex, you can use any of the Apex that you've created as a reference action. Then you have API. Through API, you can connect via MuleSoft or via Heroku if you're hosting it, or if it's an external service, or you can use an external service, external tool as well, specifically. And flow, if you have a flow created, you can call this reference. In reference action, you can call the flow that you have created. And an example could be like, whenever you create something, an action, this is how the action would actually look like when you give additional inputs. So you need to provide inputs such as like what sort of instructions, how to perform the specific action. Then after that, if you have any input output in the flow or in the Apex, this is the place where you edit any information, provide information of how should the input be, what sort of input that you need to use for this specific action, and output. If you want to have a clear format of this is your output, this is how your output should actually look like, all of this information can be provided in the instructions. So in terms of summary, we've talked about evolution of Agentforce, generic agents, types of agents in Agentforce, topic, instructions and actions, introduction to action builder. Sorry for coursing through sooner. We are going to see omni-channel connectivity in day 4 in tomorrow's session. In addition to that, we'll be talking about actions in action, flows, prompt template, Apex and external services, and Agentforce testing center in practical. Okay. Thank you, team.